Okay. So far we have seen the fluid statics and even fluid dynamics we have seen, where the fluid will be flowing from one place to another place. What are the parameters affecting the flow and all we have seen, and concluded it with Bernoulli's theorem. Then there is another important characteristic of the liquids. We don't say fluids here. This property is in particular to liquids called surface tension. So surface tension is a surface phenomenon of the liquids, in particular to liquids. The mosquitoes will be staying and breeding on the stagnant water surface. Normally, they'll be sinking in the water if they attempt to stay there, but they'll be happily walking and they'll be breeding on the stagnant water surface, because the liquid surface in equilibrium will be acting like the stretched elastic membrane. Membrane means a thin layer with elastic properties. So because of that, the mosquitoes can breed and walk. And the shaving brush, when you attempt to immerse it in water surface, the brush will spread out. Means this surface tension phenomenon will prevent the entry of the shaving brush into the water. As a result of that, the hairs will spread out. And because of the same surface tension phenomenon, liquid drops will try to acquire spherical shape. Water drops, rainwater drops falling, and mercury drop, alcohol, every liquid drop will be in spherical shape, including the soap bubbles. So this is also a surface phenomenon because of surface tension. And even the rise of water from the roots to the branches of the plant, action of fountain pen, they're all because of the surface tension phenomenon. Why all these phenomena are taking place? Because liquid has a tendency to acquire the least surface. That is, always liquid tends to keep its surface area as minimum as possible. So we'll try to see some more important points of it. One minute. Okay. Third one, surface tension. Yeah, introduction. Write these points once.
Yes, sir.
First one, mosquitoes can breed and walk. Mosquitoes can breed and walk on the stagnant water surface. Mosquitoes can breed and walk on the stagnant water surface. Right in the next line. Water drops and all the other liquid drops. Water drops and all the other liquid drops will acquire spherical shape. Will acquire the spherical shape. Next line. The liquid, the water from the roots to the branches of the plant. The water from the roots to the branches of a plant will rise through narrow capillaries. Will rise through narrow capillaries. Will rise through narrow capillaries present in the stem of the tree. Present in the stem of the tree. Second point. All these phenomena of the liquid, are because of the surface phenomenon of the liquid, or because of the surface phenomenon of the liquid.
Sir, can you repeat the sentence, sir?
All these phenomena are due to the surface phenomenon of the liquid to acquire the least surface area. To acquire the least surface area. Next point. How it arises means, again we will go to the roots of the molecular interactions. You know, between the liquid molecules, same kind of molecules, there will be cohesive forces, and between the molecules of different kind, whenever the liquid is present in a container, between the walls of the container and the liquid, so there are different kinds of molecules, there will be forces of adhesion. So the basic cause for the surface tension phenomenon to arise or to activate is nothing but the molecular interactions. Please write that point. The cause of surface tension phenomenon is a molecular phenomenon. The cause of surface tension, just enough. The cause of surface tension is a molecular phenomenon. And the cohesive adhesive forces. Give rise to this. Now let us try to define it. Here is a container. And you have taken a liquid in the container. This is a free liquid surface. We cannot draw any line, but we can imagine a line. So here is the imaginary line drawn on the free liquid surface in equilibrium. Then these molecular forces, whatever I am referring, will be assumed to be acting on either side of this imaginary line, like this. So they are called surface tension forces. How they will be? They'll be perpendicular to this imaginary line and tangential to the liquid surface. So if the length of the imaginary line is L and the tangential force acting is F, per unit length of this imaginary line, what is the force? So F by L, this is only called as surface tension represented by gamma. I repeat, the tangential force acting at right angles per unit length of an imaginary line drawn on free liquid surface in equilibrium is called as surface tension. So its SI unit is Newton meter inverse, CGS unit force by length kada, dynes per centimeter, relation 1 Newton by 1 meter is 10 to the power of 5 dynes by 10 square centimeters. So 1 Newton meter inverse is 10 cube dynes per centimeter. Dimensional formula, force ml t to the power of minus 2 by L. So it is m t to the power of minus 2. So surface tension is not the force, because tension, whenever we hear tension, we assume that it is a force, but it's not a force. It is force per unit length. Please write the definition, Vamsi.
Yes, sir.
The tangential force, acting per unit length of an imaginary line, the tangential force acting at right angles, per unit length of an imaginary line, on a free liquid surface, in the equilibrium. A free liquid surface in the equilibrium is called the surface tension. And is given by gamma is equal to F by L. And is given by gamma is equal to F by L. So take the units and dimensional formula. If you complete, you tell me.
Yes, sir. Done, sir.
Okay. Fifth point. I told you already the cause of surface tension is because of molecular phenomenon, that is cohesive forces means intermolecular attractive forces between the molecules of same kind. Adhesive forces means intermolecular attractive forces between the molecules of different kind. And this theory is named, explained by Laplace, and this theory is called as molecular theory of surface tension. Okay, just
Yes,
make a
sir.
small reference of it. Laplace explained the cause of surface tension. Laplace explained the cause of surface tension. మీకైతే అక్కర్లేదు అసలు అమ్మాయి కోసం చెప్దాం అనుకున్నాను, అమ్మాయి కొట్టేసింది.
Yes, sir.
Laplace explained the cause of surface tension with the help of molecular theory. With the help of the molecular theory of surface tension, in which he considered intermolecular attractive force between the molecules of, we have two types. What are they? Same kind, different kind. So the intermolecular attractive force between the molecules of same kind, it is called cohesive force. And intermolecular attractive force with the molecules of different kind, this is adhesive force. And here there is a range of molecular influence. This is called as molecular range. And imagine here is the sphere. So you can imagine there is a molecule, dot is a molecule, and the dotted lines is the sphere. All the molecules coming within this sphere will only experience the molecular interactions. So this sphere, imaginary sphere, is called as sphere of molecular influence. Either molecular range or the radius of molecular influence will be in the order of size of the molecule. So size of the molecule means this will be around 10 to the power of -8 centimeters. Okay.
Yes, sir.
So taking all these things into consideration, Laplace explained the cause of this molecular surface tension and the behavior of a free liquid surface in equilibrium as stretched elastic membrane. So a lot of big theories there. For the time being, this is enough for you. Okay.
Yes, sir.
Then the next one is surface energy. ఎప్పుడైనా ఈ వైర్ ఫ్రేమ్ సోప్ సొల్యూషన్ లో పెట్టి బబుల్స్ ఫామ్ చేసావా?
No, sir.
అమ్ముతూ ఉంటారు కదా, అది సర్కులర్ రింగ్ లాగా చిన్న
Oh, yes, sir. Yes, sir. Jason, sir.
దాన్ని సబ్బు నీళ్ళలో ముంచేసి పైకి తీసుకుంటూ ఉంటే
Yes, sir. Yes, sir.
సో ఇన్స్టెడ్ ఆఫ్ సర్కులర్ వన్ we took a rectangular frame. Okay.
Yes, sir.
In this rectangular frame, say I'll call it as A, B, C, D. AB is a wire which slides, sliding wire. Okay?
Yes,
You
sir.
hold this wire frame and immerse in the soap solution and gently you lift it. Don't blow the bubble. Gently you lift it. You'll find a film, soap film on this frame. So this film will have two layers. One will be above the frame. Other one is the below the frame. ఈ రెండు లేయర్స్ కలిస్తేనే ఫిల్మ్ ఫామ్ అవుతుంది. దాన్ని బ్లో చేస్తే మనకి ఎయిర్ బబుల్ వస్తుంది, సోప్ బబుల్ వస్తుంది కదా.
Yes, sir.
So if you gently lift it and observe, you will find the wire frame tends to move inwards. How it is trying to move inwards? Because the surface tension phenomenon I told you, all the liquid drops will acquire spherical shape. The liquid surface behaves like a stretched elastic membrane. All these properties are because of the tendency of the liquid surface to acquire the least possible surface area. So for that, the surface tension forces will be acting inwards because AD, CD, BC, they are fixed, they are not movable. AB is movable, so we will find the sliding wire AB gently moving inwards. But if you can apply a force F, which is equivalent magnitude and opposite in direction to the surface tension force, and you could displace this wire frame from AB to A1, B1 through a distance X, then what happens? The area of the surface film will increase. Yes or no?
Yes, sir.
So the work done in increasing the surface area of a surface film against the surface tension forces will be stored in the film as energy, and that energy is called as surface energy. Understand?
Yes, sir.
Please write the definition. Definition: work done in increasing the surface area, work done in increasing the surface area of a surface film, work done in increasing the surface area of a surface film against the surface tension forces. Work done in increasing the surface area of a surface film against the surface tension forces will be stored in the film as surface energy. Surface energy. So ikkada surface energy is equal to W is equal to Fx, that is F gamma into X. Kata F gamma into kada gamma is equal to surface tension forces by effective length. Ikkada effective length ఏమవుతుంది? 2 into small l. L is nothing but AB. So length of the sliding wire L అయితే effective length 2L అంటున్నా. Effective length ఎందుకు అంటున్నావు? సోప్ ఫిల్మ్ లో ఎన్ని లేయర్స్ ఉంటాయి వంశీ?
Yes, sir.
ఫిల్మ్ లో ఎన్ని లేయర్స్ ఉంటాయా?
Sir, 2, sir.
చెప్పు, ఇక్కడ రాసాను ఆల్రెడీ. One is above the frame, other is below the frame.
2, sir. Yes, sir. 2, sir.
So each layer will have a length equals to L. అవునా?
Yes, sir.
So the surface tension force will act on both the layers. Yes or no?
Yes, sir. Yes, sir.
ఒక లేయర్ మీద యాక్ట్ చేసి ఇంకో లేయర్ మీద యాక్ట్ చేయకపోతే ఫిల్మ్ బ్రేక్ అయిపోతుంది.
Yes, sir.
So if you want to keep the film as it is, you must apply the force on both the film, both the layers. Hence, the effective length will be 2L. Therefore,
Yes, sir.
it will be F gamma by 2 into small l. So, surface tension force is 2L into gamma. Antena?
Yes, sir.
Therefore, the surface energy is 2L into gamma into x, or is equal to gamma into 2 into Lx. L అంటే ఏంటి? లెంత్ కదా,
Yes, sir.
x అంటే బ్రెడ్త్ కదా,
Yes, sir.
లెంత్ ఇంటూ బ్రెడ్త్ ఏమొస్తుంది? ఏరియా కాదా?
Yes, sir. Yes, sir.
It's area, yes or no?
Yes,
A
sir.
is the length, x is the breadth, so it is area.
Yes,
What
sir. Yes.
area? Initial area or final area or increase in area? Shaded portion area ఏమని చెప్పాను నేను?
Sir, the increased one, sir.
Increased one. Therefore, L into x will be increase in area. అంతేనా?
Yes, sir.
Therefore, I can write now it is gamma into 2 into
Increase in area, sir.
increase in area. So I can write surface energy as gamma into A2 minus A1. So 2 into increase in area will be increase in area of the film. Antena?
Yes, sir.
So this is the formula for surface energy. Okay?
Yes, sir.
Then using the capillarity method, the surface tension gamma can be found using the formula RH rho g by 2 cos theta, and this theta is called angle of contact. ఇప్పుడు మెర్క్యూరీని చూసావా?
Yes, sir.
గ్లాస్ ట్యూబ్ లో మెర్క్యూరీని చూస్తే ఈ షేప్ లో ఉంటుంది, పర్ఫెక్ట్ హారిజాంటల్ ఉండదు. అబ్జర్వ్ చేశారు లేదా?
No, sir.
జాగ్రత్తగా చూస్తే ఫ్లాట్ గా ఉంటుంది అది. ఇట్ విల్ బి హ్యావింగ్ కాన్వెక్స్ షేప్. ఆల్కహాల్ మెర్క్యూరీ విల్ హ్యావ్ కాన్వెక్స్ షేప్, కోకోనట్ ఆయిల్ కానీ ఇవన్నీ కాన్కేవ్ షేప్ ఉంటాయి. సో దిస్ యాంగిల్ మేడ్ బై ద టాంజెంట్ విత్ ద సాలిడ్ సర్ఫేస్ ఇన్ కాంటాక్ట్ ఈజ్ కాల్డ్ ద యాంగిల్ ఆఫ్ కాంటాక్ట్. ఇదంతా లిక్విడ్ కదా.
Yes, sir.
So here is a solid. So angle made by the tangent drawn to this liquid surface with the solid surface is called the angle of contact, and R, radius of the capillary tube, H, the capillary rise. So if you keep a capillary tube in a liquid, liquid will rise into that. ఏదైనా స్ట్రాన్ పెట్టి నీళ్ళలో గ్లాస్ నీళ్ళలో పెడితే ఏమవుతుంది? నువ్వు పీల్చకపోయినా కొంత వాటర్ పైకి వస్తుంది, అవునా కదా?
Yes, sir.
That's called capillary rise. And rho, density of the liquid. And you know G is acceleration due to gravity. Then the formula for surface tension is given by RH rho g by 2 cos theta. So in this, for pure water in glass container, theta is equal to 0 degrees. Therefore, gamma becomes equals to RH rho g by 2. Units, Newton meter inverse. So this is how we determine the surface tension of any liquid, not only water, any other liquid. Another two important points in this. First one is gamma naught and gamma T. Surface tensions of liquid at 0 degrees centigrade and T degree centigrade, then gamma T surface tension decreases with the rise in temperature according to the formula gamma T is equal to gamma 0 into 1 minus alpha T. This alpha is called temperature coefficient of surface tension. Tarvata addition of impurities decrease the surface tension. Rise in temperature decrease the surface tension. And water with decreased surface tension will give the better cleansing effect. The theories are even plus 2 lo kuda ledu. So just I am making a reference. Water with decreased surface tension will give better cleansing effect. అందుకనే పూర్వం నుంచి కూడా పూర్వం ఈ గ్యాస్ స్టవ్లు అవి లేనప్పుడు మన ఇళ్లలో పల్లెటూళ్ళలో ఒక నీళ్ల పొయ్యలు సెపరేట్గా ఉండేది దొడ్లో. ఈ ఎండిపోయిన కర్రపుల్లలు, తర్వాత తాటి చెట్టు కమ్మలు, కొబ్బరి మొక్కలు ఇవన్నీ పట్టుకొచ్చి ఇంట్లో గ్యాదర్ చేసి పెట్టేవారు పక్కన. ఉదయాన్నే పొయ్యి అంటిస్తే పీపుల్ యూస్ టు హ్యావ్ హాట్ వాటర్ బాత్. వేడి నీళ్ళు కాదు, గోరువెచ్చని నీళ్ళు. ఎందుకంటే బాడీ విల్ బి క్లీన్డ్ ఎఫెక్టివ్లీ in a better way than the cold water using the lukewarm water, because we can prove by physics that the lukewarm water will give more cleansing effect. With the rise in temperature, surface tension decreases. Water with decreased surface tension can clean the body more effectively. అలాగే చాకళ్ళు వాళ్ళకి సర్ఫేస్ టెన్షన్ అవి తెలియవు పల్లెటూళ్ళలో. నువ్వు ఎప్పుడైనా చూసేవారో తెలియదు, కానీ పల్లెటూళ్ళలో ఏం చేసేవాళ్ళు అంటే, వంశీ ఉన్నావా క్లాస్ లో?
yes sir.
యా, ఈ చాకరాళ్ళు అందరూ ఏం చేసేవాళ్ళు, ఇంటింటికి వచ్చి ఒక రోజు పెట్టుకునేవారు వారంలో. ఆ ఇంటికి వచ్చి ఆ బట్టలన్నీ కలెక్ట్ చేసుకుని పట్టుకెళ్ళి పెద్ద కుండతోటి పెద్ద కుండ ఉండేది చెరువు పక్కన. ఆ కుండలో బట్టలన్నీ వేసేసి చాకలు చౌడంటారు ఏదో కెమికల్ అది వేసి నీళ్లు పోసి దాన్ని వేడి చేసేవారు, కింద మంటెట్టేవారు.
yes sir.
బాగా వేడెక్కిన తర్వాత ఆ నీళ్లు గుడ్లన్నీ పైకి తీసి బండకేసి బాధితే బ్రహ్మాండంగా ఉతికేసేవారు వాళ్ళు. వాషింగ్ పనికిరావు, బ్యూటిఫుల్లీ దేవర్ చాలా వైట్ బ్రహ్మాండంగా ఉండేవారు అన్నమాట క్లోత్స్. విస్త్రీ కూడా పర్ఫెక్ట్ గా చేసేవారు.
yes sir.
Because hot water cleans the clothes more effectively than cold water. ఇప్పుడు వాషింగ్ మెషిన్స్ లో ప్రొవిజన్ వస్తుంది, అది చూసావు లేదో, లేటెస్ట్ వాషింగ్ మెషిన్స్.
yes sir. yes sir.
Yeah, you can allow the hot water to go into the chamber. That cleaning chamber లో పంపించే ఫెసిలిటీ ఉంది. ఎందుకంటే hot water cleans the clothes more effectively than cold water, because water with reduced surface tension gives the better cleansing effect. Alage lukewarm water can clean the utensils more effectively than cold water. Tarvata పూర్వం ఈ పొయ్యి బుగ్గి అంతా దాచేవారు, ఏది వేస్ట్ చేసేవాడు కాదు. మన కన్సర్వేషన్ గురించి వెస్టర్న్స్ మనకి చెప్పక్కర్లా. ఇండియన్స్ know about the conservation of nature more better than the Westerns. In fact, they are the destroyers of nature. Indians were the conservers of nature. ఆ పొయ్యి బుగ్గి అంతా చోట పెట్టేవారు, పెట్టి దాన్ని కొబ్బరి పీచు తోటి గిన్నెలు తోవడానికి ఉపయోగించేవారు. మీన్స్ ఇంప్యూరిటీస్ యాడ్ చేస్తే క్లీనింగ్ ఎఫెక్ట్ విల్ బి మోర్. సో ఎడిషన్ ఆఫ్ ఇంప్యూరిటీ విల్ డిక్రీజ్ సర్ఫేస్ టెన్షన్. ఆ నీళ్లకి ఆ పొయ్యి బుగ్గిను కొబ్బరి పీచు యాడ్ చేయడం వలన impurities decrease అయ్యి cleansing effect పెరిగేది.
yes sir.
Yeah, similarly use of detergents in cleaning clothes is also based on this principle. Use of soap and shampoo for cleaning our body and hair is also based on this concept. So in India, the dhobis were knowing about surface tension, carpenters were knowing about the thrust and pressure, Like that, even farmers were knowing about the biology. They don't know the science, but they know the technology. Means our rishis and saints, పూర్వం మన భారతదేశంలో ఋషులు తర్వాత వీళ్ళందరూ మన ఋషులు తర్వాత ఋషి సాంప్రదాయం యోగులు ఋషులు వీళ్ళందరూ కూడా ఈ జ్ఞానాన్ని అంతటిని వాళ్ళు తెచ్చుకుని దాన్ని మనిషికి మంచికి ఎలా సొసైటీకి సమాజానికి ఎంత మంచిగా వాడచ్చు, how best we can use the principles of science for the better living standards of the mankind అనేది వాళ్ళు ఐడెంటిఫై చేసి they just passed on the techniques. That he even didn't reveal the technology, though we need not know the concept of surface tension, but he or she is able to apply. That's enough. So that was the philosophy in India, that the scientific knowledge was kept a secret and the techniques of science through technology were passed out to the public for improving their living standards. So this is how we have the influence impact of surface tension in our daily life. Okay.
Yes, sir.
So I don't claim that we finished this, but for you this is enough. I skipped
Yes,
two
sir.
derivations here. One is the derivation of surface energy, and second is the derivation of formula for surface tension of a liquid. These two derivations are there, which you don't need. I skipped them. Angle of contact
Yes, sir.
explanation also I skipped, because at this level of 10th class study you don't need it. Just basic definition and applications are enough for you. But still, I went ahead. So we'll conclude. Have you copied them?
Yes, sir. Yes, sir.
Okay, we'll conclude the class today. Monday we'll be doing the radioactive. I think CBSE lo unnatledu radioactivity.
Yes, sir.
But you can hear. Evana Olympiad exams ki vaatiki panikostundi. You can hear that. So Monday and
Yes,
Tuesday
sir.
we finish that, and we'll plan accordingly as I informed you. Right?
Yes, sir. Yes, sir.
Okay. Bye.
Bye, sir. Sir, like tomorrow, are we having any classes, sir?
Tomorrow?
Are you having any classes, sir?
No. Why?
So, like I just asked, sir.
No, I'm free only. I thought
Yes,
of
sir.
taking your class. Radioactive. I thought of finishing it tomorrow.
Yes, sir.
బట్ మా చుట్టాలింట్లో లక్షవత్తులు నోవు ఉంది రాత్రికి.
Yes, sir. Okay, sir. Yes, sir.
అందువల్ల రేపు అవైలబిలిటీ కష్టం ఉంది, అందుకనే లేకపోతే యాక్చువల్గా రేపు పెట్టేద్దాం అనుకున్న క్లాస్ మీది.
Yes, sir. Yes, sir.
అండ్ రేపు ఈవినింగ్ యాక్చువల్లీ మండే మార్నింగ్ ఏఎస్లో నగర్లో ఉపనయనం ఒకటి ఉంది.
Yes, sir.
కానీ మరి మండే అంటే మళ్ళీ కాలేజ్ మాడడం కష్టం కాబట్టి రేపు ఈవినింగ్ ఏమైనా వచ్చి కనపడి వెళ్దామని ప్లాన్ చేస్తున్నాం. వస్తే ఐ విల్ కాల్ యూ.
Okay, sir. Yes, sir. Yes, sir. Please.
ఓకే, కొంచెం మరి ఇల్లు కొంచెం మర్చిపోయాను నేను, ఆ దగ్గరలోకి వచ్చిన తర్వాత కాల్ చేస్తాను.
Okay, sir. Ready, sir. Okay, sir.
ఇంట్లో ఉంటారా, ఎక్కడికైనా వెళ్తారా?
Sir, ఇంట్లోనే ఉంటాం, sir.
ఓకే ఫైన్, ఐ విల్ కాల్ యూ.
Okay, sir. Yes, sir.
రైట్, బాయ్.
Thank you, sir. Thank you, sir. Good evening, sir.
ఓకే.